In this video, we will define and analyze an exponential function. So there are a lot of applications for exponential functions. For example, in science, we use exponential functions for growth models and decay models. We also use exponential functions in finance. So let's begin by defining what is an exponential function. So an exponential function has the form f of x equals a to the bx, where a cannot be 0 and b cannot equal 1. Okay, so we have this function, f of x equals a to the bx. Now when you have a to the bx, the b we call the base of the function. And we use that term base all the time when we do work with powers. And then a is our multiplication factor. Okay, now there are a couple of requirements. Requirement number 1 is that a cannot be 0, and that makes sense. If a is 0, then the whole function's gone, and it's no longer an exponential function. And the other requirement is that b cannot equal 1, and I actually think I also need to do this. B has to be greater than 0. Glad I caught that. So if b is 1, then you would basically just have 1 of the x, which is 1. So again, that's not an exponential function. And then b cannot have a negative. You can't have a negative base in there. Because what starts happening is then you start getting into imaginary numbers, and we don't want that. Okay, so let's start off with how to evaluate an exponential function on a calculator. So how to evaluate an exponential function on a calculator. So let's say for part A, we have f of x equals 8 to the x power. Okay, so in this particular case, we have a function. The base is 8, so if we go back to this a, b to the x, the base is 8. A is just 1, which happens a good amount of the time, so that's okay. And then we raise it to the x power. Now let's say we want to look at f of, I don't know, pi, which is 8 to the pi power. Okay, now everybody's calculator is slightly different, but for a lot of calculators, the process of finding an exponent is basically the same. Okay, so I turn on my calculator, and I'm going to hit 8. And then up here, at least on the TI-84, there's a little caret. So I'm going to hit that caret. Now some of the newer calculators, when you hit that caret, it actually takes the cursor and moves it to the upper part of the number, but sometimes it just puts the caret down. Does the same thing. It means it's raising it to, in this case, pi. So if you put that in there, you should get, oops, I should write approximately 687.2913. Alright, so for this class, we're going to go ahead and use 4 decimal places in our answer. Be careful, the book will only give you a couple. I do ask for a little bit more, but anyways, that's just to kind of make sure I see what you're getting in your answer. Okay, let's try another one. B. here we have f of x equals 8 to the negative x. So what is f of 1/2? Well, that's the same as 8 to the negative 1/2. So let's see what that approximately equals. So we have 8 raised to the negative 1/2. So notice how I put that in there, 8 caret, and then I did open parentheses. So when you work with fractions, unless yours actually goes to the exponent when you hit your calculator, you might want to use parentheses to make sure the whole thing becomes the exponent. And that ends up being 0.35355. I actually didn't put in one extra one, so it'd be what? 0.3536. All right, let's try one more. See, f of x equals 0.8 to the x power. And what if we want f of a negative 2.5? So that would be 0.8 to the negative 2.5. So let's get that in there. So we put 0.8 raised to the negative 2.5 power. And we get 1.7469. Good. So we are using our calculator a lot in this kind of section with exponential functions and logarithmic functions. So we do need to know how to operate them. All right, now let's look at graphing an exponential function. Okay, so let's say for an example, we want to sketch a graph of f of x equals 3 to the x power. Alright, so when we sketch a graph of f of x equals 3 to the x power, we're going to use basically a parent function technique to do this. But with this parent function technique, there are going to be 3 points that you always need to graph, and those 3 relative points, depending on where we move this. So we're going to look at x equals 0. So that means f of 0 equals 3 to the 0. Now one thing we remember from our study of exponents is that anything to the 0 power is 1. Okay, so then how about when x is 1? So f of 1 is 3 to the first power, which equals 3. And then x equals a negative 1. So f of a negative 1 is 3 to the negative 1 power. And then you remember, if you have a negative in the exponent, to make it positive, we put in the denominator, so we get 1/3. Okay, so let's sketch this. And so we have the point 0, 1, 1, 3, and negative 1 and 1/3. So let's see here, 1, 3, 0, 1, negative 1 and 1/3. Good. And there's a good graph of f of x equals 3 to the x power. Okay, so now a couple things to note. The big one is, notice that how we graphed this, it got closer and closer and closer to the x-axis, but it actually never touches the x-axis. And that's because this axis is a horizontal asymptote. So at y equals 0. So exponential functions have horizontal asymptotes. Okay, so in this case it's y equals 0, but depending on where we move it, that's where the horizontal asymptote goes. Alright, so there's the first graph that we made of an exponential function. Now again, and I'm just saying this right now, that for my class, when you graph an exponential function, we know the general shape, but you always graph these 3 points. I will always expect those.